Characterization of N and O atoms of N, A, and N2X v13 Metastable molecules and N+ ion densities in ARN afterglows plasmas from microwave discharges. This important article is authored by the following scientists. The findings underscore the potential of N, A, and N+ species to enable sustainable and efficient surface treatments with applications ranging from medical devices to advanced material coatings. Afterglow jets of ARN flowing microwave discharges are characterized by optical emission spectroscopy. The N and O atoms, the N, A, and N2X v13 metastable molecules and N+ ion densities are determined after calibration by no titration for N and O atoms and measurements of No and N band intensities. For an ARXN gas mixture with X increasing from 2 to 100% at 4 torr, 100 watt and an afterglow time of 310 superscript 3 s at the 5-liter reactor inlet, it is found densities in the ranges of 2 to 6, 10 superscript 1 cm superscript 3 for N atoms, 1 order of magnitude lower for N2X v13 and for O atoms, coming from air impurity, of 10 superscript 1 10 superscript 1 superscript 1 cm superscript 3 for N, A, and of 1010 cm superscript 3 for N+. Thank you for watching this video. Please subscribe to our channel BP International to watch more videos in the fields of science, technology and medicine.